In this video I am going to discuss about few important problems related to singular solutions. As you can see, I have initially mentioned that we have to find out the singular solutions for the following structures. Now let us discuss about the first one. Here you can see the first equation is given by xp square minus of x minus a whole square, that is equal to 0. Now we all know that p stands for dy dx. So first of all, let us try to solve this one for p. So technically we can write p square is equal to x minus a whole square whole divided by x from this equation, and so that p can be rewritten as x minus a whole divided by root over x. Now obviously x divided by root x, as you can see, that means x divided by x to the power half, so it will be x to the power half, and minus a x to the power minus half. So we have plus minus sign in front of this expression. Now let us replace p by dy dx, and hence you can say dy dx will be equal to plus minus of x to the power half minus a into x to the power minus half. And so using the concept of separation of variables, we can separate dy and dx also, and after integration we may get from this part. I have used constant of integration on the left hand side, so I have obtained y plus c. On the right hand side, first part will be what? X to the power half plus 1 whole divided by half plus 1, that means x to the power 3 by 2 whole divided by 3 by 2. So take the reciprocal, it will be 2 by 3 x to the power 3 by 2. Similarly, from the second part, a into x to the power minus half plus 1 whole divided by minus half plus 1, that will ultimately give you minus 2a x to the power half. This is 2a x to the power half. So y plus c, if we take 2 by 3 root x as common, then ultimately it gives you x minus 3. As usual, you can see plus minus sign is there. So c is the arbitrary constant. Now squaring both sides, you will get the second equation. Now from the first one as well as from the second equation, let us try to find out the p discriminant as well as c discriminant. Now you can see the first equation can be observed as a quadratic equation in terms of p. So you can simply find out p discriminant by using the concept of b square minus 4ac. So here there is no term related to p, that means b should be equal to 0, and simply we are using b square minus 4ac, so it will be 0 minus of minus, that means plus 4 into x into x minus a whole square. So that's why I have written directly the p discriminant relation gives you 4x into x minus a whole square. Ultimately, if you can remove 4, so x into x minus a whole square. Now similarly, from the equation 2, you can see y plus c whole square can be rewritten as what? C square plus 2cy, that is equal plus y square minus what? Minus 4 by 9 into x minus 3a whole square. So c discriminant relation can be obtained as what? Here you can see b, that is, if you compare this equation with ax square plus bx plus c, then you can see coefficient of c is in this case 2y, so you can find out square of it because it resembles to b in this question. So 4y square minus 4, that means 4ac term will appear right now, minus 4, a refers to 1, and obviously c refers to what? Minus 4 by 9 x into x minus 3 a whole square plus y square. So after simplification, you will get 16 by 9 x into x minus 3 a whole square, that is equal to 0, and finally you can see x into x minus 3 a whole square equal to 0. Now this is our p discriminant, this is our c discriminant. So you can see from both these relations, x equal to 0 appears only once in both these discriminant relations. That means you can say x equal to 0 is the required singular solution. And also, if it is necessary to find out the tag locus and node locus, then you can see from the first part, that is from the p discriminant relation, x minus a appears only under p discriminant relation, and also it appears twice, so it will be the required tag locus. And similarly x minus 3a, it appears in the c discriminant relation and also appears twice, so it will be the required node locus. And I hope you know the format for tag locus and node locus is given by en square cq and et square c, etc, etc. So in general, these parts are not required for your examination, but mainly you have to find out the singular solution. And one more thing, I have written here s dot s, that means I have abbreviated singular solution as s dot s, but usually you should not write in your examination like s dot s, you have to write totally singular solution. So here in the first problem we have obtained x equal to 0 is the required singular solution. Another important thing to observe is that it is not necessary that every time you will get a quadratic equation in terms of P or quadratic equation in terms of C. In those cases, in order to find out the eliminant, you cannot apply the concept of b square minus 4ac. Rather, you have to take the help of partial derivative. Remember, already we have done the concept of envelope, where we have differentiated partially the main equation with respect to the parameter. Whenever you are considering any equation which is of higher degree than 2, then in order to get the p discriminant and c discriminant, you cannot take the help of this b square minus 4ac. Now let us discuss about few problems like this. Now I am going to discuss a very important problem in the next one. Here you can see, even I have written this one, that is very important. This particular question comes under several times in different universities, in North Bengal University, in Calcutta University, etc., etc. 8p cube minus 27 into x, 12p square y. So I have obtained the value of y from the first equation. Also you can see this part can be written as 8 by 12, that is 2 by 3, cancelling the common factor 4. P cube by p square will give you p, then we have x. Then we have 27 by 12, just cancel the common factor 3, 9 by 4 will be there, x by p square. Now first let us try to find out the general solution, then we can eliminate the arbitrary constant c, and later we will see what will be the character for p discriminant and c discriminant. So differentiating both sides with respect to x, we get dy dx, that is p. Normal differentiation will give you 2 by 3 into p, then 2 by 3 into x dp dx. Similarly from the second part, minus 9 by 4 p square x with respect to x, whenever you are differentiating, will give you 1. Then we have minus 9 by 4, x remains fixed, 1 by p square, it will ultimately give you minus 2 by p cube. So 2 will be cancelled, so it will be 2 minus minus plus, then p cube will be there, and also dp dx. Now you have to separate the terms related to dp dx and all other specific terms. Now after some simple calculation, that is by choosing x dp dx as common, you will get this type of structure. From the next two factors, I have considered minus p by 2 as common to get the same factor. Ultimately we have obtained this type of expression. Now here you can see dp dx related factor is given by x dp dx minus p by 2 equal to 0. So separating the variables in terms of p and x, we can integrate it. The first part shows you, after integration you will get 2 log p is equal to log x plus log c. C is the constant of integration as mentioned earlier. So 2 log p, that is equal to log x plus log c. That means what? You can rewrite this expression as p square equal to cx. So this is equation 2. Obviously the first one is equation 1. Now from equation 1 you can see 8p cube minus 27 was there. So 8p into p square. I have intentionally rewrite this equation in this form, that minus 27 is as usual there, right hand side gives you 12p square y. Now p square is equal to cx, so 8p cx minus 27x, then 12 p square is again cx into y. You can see I have underlined x because you can cancel out x from both sides, so that you will get 8p cx, that is equal to 12 cy plus 27. Already x is cancelled, so 8 pcx whole square, that is equal to 12 cy plus 27 whole square. Simple calculation will give you 64 p square c square x square. Also on the right hand side take 12c common, then you will get y plus 9 by 4c. Obviously everything is within bracket and you can take the square of this expression. Now p square is again cx from equation 2. So p square is cx, c square x square, 144 c square, y plus 9 by 4c whole square. So ultimately cancelling c square from both sides, you will get cx cube on the left hand side, 144 by 64, y plus 9 by 4c whole square, and I'll say you will get x cube, that is equal to what? After cancelling this entire expression by 16 into 9 144, and 16 into 4, that is 64. So 9 by 4c, y plus 9 by 4c. So here you can see 9 by 4c can be again considered as a new constant, so I have taken the same thing. In the next page you will see 9 by 4c, intentionally this can be written as what? K, that is a new constant. So whenever we are considering this new constant, the modified equation will look like x cube minus k into y plus k whole square. Now we can differentiate this expression with respect to k. So k is the new parameter, as if we can assume. So it will give you minus y plus k whole square. Then obviously k remains fixed, minus 2 into y plus k. After simplification you will get two factors, one is y plus k, another one is y plus 3k. Now equating these two expressions separately with 0, you will get y is equal to minus k and y is equal to minus 3k. Whenever you are putting y is equal to minus k, this equation will give you x cube equal to 0. Now don't reduce it as x equal to 0. X cube equal to 0, keep this one intact. Similarly, y is equal to minus 3k. After putting this expression in this equation 3, after simplification you will get 27x cube plus 4y cube equal to 0. So the C discriminant relation that can be obtained here is nothing but one possibility is x cube, second possibility is 27x cube plus 4y cube. So combining these two, you will get the C discriminant relation like this. Here also I have mentioned under which form you have obtained this one, E n square C cube form. So it is not required to be written in the examination, but simply for your understanding I have written this one. Again we have to find out the P discriminant relation. This is the main problem. So from here you have to find out P discriminant. So here you cannot directly use the concept of B square minus 4AC. Remember I told you a little while ago that whenever the structure involves P square, then it's perfect to obtain B square minus 4AC type of structure. But here you can see it is a cubic equation in terms of P. So first let us differentiate this expression partially with respect to parameter P, and automatically you will get what, 24 p square x, because x is there, and on the right hand side 24 py. So here you can see I have written the same thing, 24 p square x, that is equal to 24 py. So p square x minus py equal to 0, p can be taken common, automatically either p equal to 0 or p equals to I by x. Now you can easily realize what is your next task. Simply you have to put p equal to 0 in this particular equation. After putting p equal to 0, you can also understand this part will be 0, minus 27x equal to 0, that means x equal to 0. Also p is equal to y by x should be used here to get the modified result. So in this equation, first time we are putting p equal to 0, then we are putting p is equal to y by x. As you can see, I have calculated all these things in the next page. That is, putting p equal to 0, I have obtained x equal to 0, and putting p is equals to I by x in equation 1, I have obtained this expression. Even I have highlighted this portion, 4y cube plus 27x cube. So combining these two relations, again we can write the expression can be considered as what, x 4y cube plus 27x cube, that is equal to 0. But here you can see intentionally I am writing this one as what, x cube into 4y cube plus 27x cube, that is equal to 0, in order to maintain the form of et square c. So finally you can see which part is common. Obviously here 4y cube plus 27x cube, this portion is common and it appears only once, corresponding to this P discriminant and C discriminant relation, and hence you can consider this is the required singular solution. So you can observe this problem very carefully because it's very important, and also its approach is little bit different to the other problems. In the previous problems, whatever we have seen or whatever we have solved, we have simply obtained b square minus 4ac, but here it is not like that. Again I am saying, because p here you are not considering any quadratic of p, so that's why you have to eliminate p, or you have to obtain the p discriminant or c discriminant in some another possible way, that is by eliminating the parameters p and c. You can take the help of partial derivatives also. So this problem is very important because of its different approach. Now moving on to the next one, let us consider another important problem. Here also you can see the structure is what, p cube minus 4yp plus 8y square is equal to 0. I hope all of you can remember the pattern of Clauser's form. So here you can see, first of all I have tried to modify this given equation in the form of Clauser's equation, and then let us start the solution. So here intentionally I am considering y is equal to v square. Now you may consider why should we consider y equal to v square. Actually this type of substitution will be given if this type of question comes in your examination, so you need not to worry about it. But here I am taking y is equal to v square. So dy dx will be what? That is p, we all know. V square on differentiation will give you 2 dv dx in multiplied by v. So dv dx can be taken as p1, that means p is equal to 2v p1. So in this equation p should be replaced by 2v p1. Now I am not discussing about the calculation in detail. Simply after solving this expression by using this particular value 2v p1, after some simple calculation you will see I have obtained p1 cube, that is equal to xp1 minus v. This is xp1. So you can rewrite this expression as what? V is equal to xp1 minus p1 cube. That means definitely you can consider this is in the Clauser's form, and so its solution can be directly obtained as v is equal to mx minus m cube. Here you can see I am choosing m is the new parameter, but again this can be considered as v is equal to m into x minus m square. So intentionally I am considering the square on either side. That's why we have obtained v square, that is equal to m square x minus m square whole square. Now you can ask me why should we consider v square, but remember already we have taken the substitution v square equal to y. So utilize it. In order to use this expression we need v square. So after getting v square on the left hand side, simply we can say this is equal to y. On the right hand side m square can be replaced by a new parameter, say c. So c into x minus c whole square. Now again, in order to get the p discriminant relation, several times I told you we need to eliminate p anyhow. Because of that we are differentiating the main equation with respect to p. Obviously this is a partial differentiation. So you will get 3p square minus 4xy, and this part will be 0 with respect to differentiation under p. So from here you will get p square equal to 4xy by 3. Now you can eliminate the value, or you can use the value of p obviously in this equation 1 that has been obtained from 4. So that's why I have written, now eliminating p from 1 using equation 4 we get, simply put this value in the main equation. You can see p cube minus 4xyp is the original equation. Take p common, you will get p square minus 4xy plus 8y square is equal to 0. P square can be replaced by 4xy by 3 as you can see from equation 4. Then minus 4xy as usual there. Again simple calculation ultimately gives you 3y square equal to pxy. Just take the square on either side. Now whenever you are taking the square, again you can see p square will appear. Now p square will be replaced by 4xy by 3. So that's why in the next part you can see 4xy by 3 x square y square, that is equal to 9y to the power 4. Now modify this expression to some extent. After simplification you will get y cube into this, that means y square into y, 27y minus 4x cube will be the final structure. This is in et square c form. That means you have obtained the envelope portion, Tacks-Locus portion and Cauchy-Locus portion. Then again you have to obtain c discriminant, that can be obtained by differentiating equation 3. So here simply differentiate this particular expression with respect to c. Again you can see if you split this expression you will get a cubic in c. That's why directly you should not apply b square minus 4ac concept. So here after differentiating you will get two factors, obviously after rearrangement. One is x minus c, another one is x minus 3c, which will give you two possible solutions regarding x. Now putting x equal to c in this equation 3 you will see y equal to 0, and also you can see putting x equal to 3c you will get a specific value. Now x equal to 3c means c will be x by 3. So put c is equal to x by 3 in this expression of y, and from there on you will get 27y minus 4x cube equal to 0 after simplification. So required c discriminant can be obtained as y multiplied by this expression. So this is in the form of en square c cube. So ultimately you can see y and 27y minus 4x cube, both of them are present in the p discriminant and c discriminant relation only once, and hence they are considered to be what? Obviously singular solution. And definitely y is equal to 0 is the Tacks-Locus because it occurs twice. Where? In the p discriminant relation. That's why you can have the final answer. This will be your required singular solution, and y is equal to 0 is the Tacks-Locus. Again I will say Tacks-Locus, node locus, you need not to say anything about it. unless it is mentioned in the question. Simply provide information corresponding to singular solution. Now we have a relatively easy problem. Question number 4. Here you can see y is equal to x dy dx plus a dy dx whole divided by 1 root over 1 plus dy dx whole square. Simply replace dy dx by p. First of all, just observe this is in the Claubert's form, so directly you can write the complete primitive or general solution is given by this, replacing p by c. Now this is your parameter c, so equation 1 should be differentiated with respect to c. Accordingly, after differentiation you will get what? This part is 0, cx will give you x plus ultimately a by root over 1 plus c square, then a into c. This part should be differentiated, that's why minus half 1 plus c square whole to the power minus 3 by 2 into 2c will appear. Now simplify this expression. After simplification you will get x plus a by 1 plus c square whole to the power 3 by 2, that is equal to 0. From here you can obtain the value of x. Now once you have obtained the value of x, simply you can use this value in the main equation, that is in equation 1. Actually in the main equation means I suggest the general solution. Then from here you will be able to find out what? You will be able to find out the value of y. You can see I have used the value of x in equation 1 so that I can obtain the value of y. After simplification again you will get the value of y. So here you can obtain x to the power 2 by 3 and also from here y to the power 2 by 3. Now whenever we are considering x to the power 2 by 3, first of all I am taking the square on either side because I want to eliminate this minus. So x square will be a square by 1 plus c square whole to the power 3. Then I am considering cube root of that expression, so that on the left hand side you will get x to the power 2 by 3, and obviously the result will be a to the power 2 by 3 by 1 plus c square. Now on the right hand side, again from the second expression, that is from equation 3, you will get y to the power 2 by 3 will be what? A to the power 2 by 3 c square whole divided by 1 plus c square. So adding these two relations we get a to the power 2 by 3 as common, and then the remaining portion will be 1 plus c square by 1 plus c square, and hence you will get the required singular solution. Here again I have written briefly as s dot s, but actually you have to write this is the required singular solution. So here you need not to find out c discriminant or p discriminant because it is directly obtained in the form of Claubert's structure, and you can directly eliminate the value of c, and that's why this particular equation is supposed to be your singular solution, which is nothing but the equation of what? Asteroid. And finally we are going to discuss about the last problem of this video, that is equation, or better to say question number 5. Again this is an application of Claubert's form, y square into y minus xp x to the power 4 into p square. This is also a very important problem. So u is equal to 1 by x, v is equal to 1 by y. I am taking this substitution, obtain du dv, so that dv du can be written as like this. Simply I am writing dv du is equal to p1 and dy dx as p, so you can obtain the value of p in terms of p1. Now whenever you are getting any value of p, simply replace that p by p1 into y square by x square. As you can see I have replaced it in the main equation. Now simply calculate the entire expression in a proper manner, so that after certain number of stages, as you can see I have shown here the proper calculation, I have obtained 1 by y minus p1 by x, that is equal to p1 square. You can see the calculation easily, you can understand it. So 1 by y is v, take this one on the other side, that means p1 by x will be there, but 1 by x is supposed to be what? U. So u p1 plus p1 square. So this is in the Claubert's form. So we can say the general solution or the complete primitive can be written as cu plus c square. But what is v? V is 1 by y. What is u? 1 by x. So again replacing u and v by 1 by x and 1 by y respectively, you will get this type of structure, which on simplification again will give you the required solution in this form. Now clearly you can see this is a quadratic equation in terms of c, so directly you can use the concept of b square minus 4ac to obtain c discriminant relation, and hence you have used this particular b square minus 4ac type of structure. That means y square will be there, minus 4 into minus x into xy. From there on you will get this relation. Now take y common to get the structure y into y plus 4x square equal to 0. Also from equation 1 you can see this can be rewritten in the form of a quadratic in p. So that's why p square x to the power 4, this will be the leading term, then plus pxy square, take this one on the other side, minus y cube. So this will be your new modified structure of equation 1. Here also you can use the concept of b square minus 4ac, that means xy square whole square minus of 4 into minus y cube into x to the power 4, that will give you this type of structure. And hence you can see x square y cube can be taken as common, so that you can obtain again the same factor y plus 4x square. So here y can be separated, xy whole square will be there, y plus 4x square will be there. So this is in the form of et square c. And finally you can say required singular solution is what? Y plus 4x square as well as y equal to 0. So this is the solution of this problem. These problems are very important. I have solved all these problems for your better understanding of this chapter, and I wish you all the best for your upcoming examination. And also I will request you to check all these problems thoroughly, so that if anyone from these problems comes in your examination you can solve it easily. Thanks for watching.